In this problem, I need to find the zeros of this function and then write it as a product of linear factors. So the first zero I'll look for is a rational zero. I'm expecting to find one of those because we have all integers for our coefficients, and so it will have to be some kind of rational zero to get that to come up. So let's see. I'm going to use the rational zeros theorem, and for that I know that P is 34 and Q is 1. And so what are the factors of 34? 1, 2, 17, and 34. And the factors of 1 are just 1. So I can have plus or minus any of these four numbers, 1, 2, 17, or 34. They're all over 1, so that works pretty easily. So in order to quickly test these values, what I'll do is I'm going to type the function into my calculator, and I'll show you the screen in just a second. Okay, so I typed in the function into the y equals screen, and then I went into table setup, and you can access this by pressing second and window. And then I made my independent variable ask rather than automatic, and that will let me type in whatever values I want, since I've got kind of a wide variety of values here. And I don't want to look at every value 1, 2, 3, 4 all the way up to 34. So when I press second graph, then I get to the table, and here's my table, and I look at the values that I have here, and I'm looking to see is there a 0 in the list, and of course there is, and that is -2. So that means -2 is a real 0. And I've got everything on here except for positive 34, so there's just the one real 0. We know with a third degree polynomial there can either be 1 or 3 real zeros, and so this is one real 0. All right. So now that I know that I have a real 0, -2, that tells me that one of my factors is x plus 2, because it's always x minus the 0. So it's x minus a -2, which is x plus 2. So I'm going to divide the polynomial that we were given by the factor x plus 2, and that'll give me a quadratic, and then I'll see how that can factor into two complex zeros. And I'll do this using synthetic division. It's a little bit quicker in terms of notation. So we've got -2 is my 0, and the coefficients of the polynomial are 1, 10, 33, and 34. The 1 comes down, and -2 times 1 is -2. 10 plus -2 is 8. -2 times 8 is -16. 33 plus -16 is 17. And -2 times 17 is -34. And 34 plus -34 gives me 0. So now I know that my polynomial is equal to x plus 2 times x squared plus 8x plus 17. Okay. So now that I have this, my polynomial is factored over the real numbers. But in this case, we want linear factors. This factor is not linear, so I have to break it down further. And in order to do that, I'm going to use the quadratic formula. Make a little space here, and let's go with the quadratic formula. So for just this, we have a equals 1, b is 8, and c is 17. So I'm going to get x equals -b plus or minus the square root of b squared, well that's 64, minus 4 times a times c. And that's all over twice a, which is 2. So that gives me negative 8 plus or minus the square root. Now let's see, 4 times 17 is 68. So we've got 64 minus 68, and that would be a negative 4. So it's negative 8 plus or minus the square root of negative 4 over 2. And so we are getting a complex solution, which is what we were expecting. And so we've got negative 8 plus or minus 2i. When I take the square root of negative 4, it's 2i divided by 2. And this is going to equal negative 4 plus or minus I. Okay, so now I can take out this quadratic, and I have x plus, oops, I want to say plus, minus negative 4 plus I, and then x minus negative 4 minus I. And let's change this just to zeros. Now we know what all the zeros are. So we've got negative 2 and then negative 4 plus or minus I. And if you wish to distribute the negative here, you can do so. You can also just leave it in this format. Either way is fine. So here we've got our linear factors, the product of the 3 linear factors, and then our 3 zeros for the function. So that's the answer to that problem.